This is just a quick reminder that you should feel free to pause the video if you ever feel you want more time to think and write. What's up, my good math maniacs? We got section 5.1, day 1. This is inverses of relations and functions. And my big question right now is what happens when you switch the input and the output? Like this. You've got a relation, and we see here that the input is, for example, 2, then the output is 4. If the input is -1, then the output is 3. If the input is -2, then the output is 0. That's the relation. That's how it's paired. If you switch the input and the output, then it becomes the opposite. 4, 2, then 3, then -1, then 0 is the input, then 2 is the output. That's an inverse relation. Interchanging the first and second coordinates of each ordered pair in a relation produces the inverse relation. We'll call that the inverse. And here's what happens if you do it with an equation. If you interchange the variables in a relation, y equals x squared minus 5x becomes x equals y squared minus 5y. Just changing the x's and the y's, putting them in different spots. Wherever you see the x, put a y, and wherever you see the y, put an x. So we've got this inverse relation going on. The original relation is in blue. Y equals x squared minus 5x. And actually, if you change it around, you see x equals y squared minus 5y. And you can even come up with a table. It might be easier to generate y values first and then back compute the x values in this direction. You see it going like that. And so if you start with a -1, for example, then you plug that in for y. What -1 squared minus 5 times -1, that's positive 6. Calculate it in that direction, and then you get points you can plot. Once you plot those points, you'll see something kind of weird going on. You'll see the same shape graph, except it got flipped. And it didn't get flipped over the x-axis or the y-axis. It got flipped over the line of y equals x, which kind of makes sense if you think about it, because you're interchanging x and y. So x became y, and then y became x. And this is what happens. It gets flipped over in this direction. It's still a parabola. It's just facing the opposite way. Here is the table from the original. We chose -1, and that calculated 6. And then when you flip it and interchange the variables, you get 6 as the input and -1 as the output. So anyway, an inverse relation can also be defined this way. If the relation is defined by an equation, like we just saw, interchanging the variables produces an equation of the inverse relation. So, next question. Let's remind ourselves how to determine if something's a function. You say the input, and then, like if the 2002 if that's the input, then the output is 37. 2006, the output is 39. And even two inputs can have the same output. That's fine. This relation is a function, yes, because every input has exactly one output. And here, this is also a relation because every input has exactly one output. You cube these numbers, and this is what you get. So yes, these originals are functions. But the next big question we're going to start asking ourselves is when we do take the inverse, when we switch the input and the output, is what we've created now also a function. And you can see here, if you switch the direction that these are going, these used to be the output, now they're the input. If the input is 44, then the output is 2009. If the input is 37, then the output is, oh, wait a minute, we've got 2. We've got 2002 or 2004. So when we take the inverse relation here, this is not a function. But this one is. You can see we've got -27 still going to -3. All these new input have exactly one output. So yes, this inverse relation is a function. I just want to take a moment to say that helium is the second element on the periodic table, and that's your audio check fact for this video. Helium. So here's the big question. Once we take the inverse, is the inverse of a function also a function? And if it is, if it is, then we call this original function 1-to-1. That's a new name, and this is what we call it. And this is not necessarily the definition. 1-to-1 function, right now we can think of as a function whose inverse is also a function. It's defined some other way, as I've indicated right here. and we'll talk about that in a second. But for right now, let's just take the inverse and let's somehow test to see if the inverse is also a function. So we've got this test, and the test that we usually use for seeing whether or not something is a function is the vertical line test. But if you wanted to test the inverse of something, you would take the inverse of the vertical line test, and that would be, if you reflect those over the line y equals x, those would turn into horizontal lines. So we do have a test for that. We can draw some horizontal lines. And this function, if we were to flip it over the line y equals x and do vertical lines, that would be the kind of same thing as just taking a horizontal line on the original. So is this function's inverse a function also? And the answer is yes, because I drew one horizontal line or many horizontal lines, and they only intersect at one point. Here, check this out. We are able to draw a horizontal line that intersects at 2 points. So if you were to flip this over the line y equals x, then it would have a vertical line that would pass through 2 of these points. Anyway, it's a horizontal line on the original, and it has more than one intersection, so no, it is not. The inverse is not a function. Here, we've drawn a horizontal line. You can draw multiple horizontal lines, and every time you draw a horizontal line, it will only pass through 1 point. So yes, it is 1-to-1. The inverse of this function is a function. Here we can draw a horizontal line that intersects more than one place. It has more than one intersection, so therefore the inverse is not a function. It is not 1-to-1. This horizontal line test basically says if it's possible for a horizontal line to intersect the graph of a function more than once, then the function is not 1-to-1, and its inverse is not a function. So we had the vertical line test, but now we've got the horizontal line test also. Just to make sure it's absolutely clear, the vertical line test tests if a relation is a function. The horizontal line test tests if the inverse of a function is a function. Therefore, for example, if it's 1-to-1. And like I said before, this is not exactly the way we define it. It's actually much easier to define it in a slightly different way. You can say a function is 1-to-1 if different inputs have different outputs. So if you know that 2 numbers are not equal to each other, then their outputs should also not equal each other. Another way to define it is if you have 2 outputs that are equal to each other, then the inputs have got to be equal to each other as well. So this is actually, for algebraic tests, this is actually a much easier way to define it. And we can use this definition to test the actual equations. You can start with this. If f of a equals f of b, then you should be able to get to this equation here as a last step. So what I'm doing here is basically a very short version of like a proof, like we did in geometry. If you want to try and prove that this is 1-to-1, you have to start with this statement always, and then it goes f of a. Well, in this particular case, f is defined as 4 minus x, so that would be 4 minus a. And this would be 4 minus b. And algebraically, we can manipulate this. We can subtract 4 from both sides, and then multiply both sides by -1. We get a equals b. If you can get down to a equals b from f of a equals f of b, then you've proven that it's a 1-to-1 function. You've demonstrated. Sometimes you can't, and it would look like this. If you ever get to plus or minus a, like if you have to take the square root of both sides, and you get plus or minus a is equal to plus or minus b, then it is not a function. Because positive a could equal negative b, and that's not what we have. That's not the end goal here. Anyway, that's notes. I'd like you to start the assignment, copy the problem list, and do the first problem of 5A1, and I'll see you in class.